Our project is called Renewable Energy to Generate Electricity for a School in Bojaya, Colombia. Our team is composed of Nicholas, Maria, Deja, and Rose. Contact emails are listed below each member's name for further inquiry. Our project is focused on Bojaya, Colombia, which currently does not have access to electricity due to the unreliable nearby power plant. Without access to electricity, the schools in the area are unable to use electronics that the government has provided for the students, which prohibits the students from getting the best education that they can. The project is focused on goal number 7 in the United Nations Sustainable Development Goals. We seek to deliver to the school Instituto Las Lomas de Bojaya, efficient, cheap, and environmentally friendly energy. The objective of our project is to ensure that we can power all of the equipment for at least 7 hours a day. We want the school to have enough electricity so that they can use all their electronics, which includes computers, fans, freezers, and TVs, when necessary to give the students the best learning experience. Our first method is using solar panels on the roof. Currently, solar panels can produce more than 200 watts per square meter. Therefore, if we have a roof of 11 square meters, we can put a solar panel of 5 square meters, which will generate at least 10 kilowatts of energy. If we install a solar panel on each building, this would generate enough electricity for the school's needs. This solution is good as it will produce enough electricity and can be installed in the school. However, it is expensive and the batteries plus the solar panels do not last and will need replaced, which does not make it as environmentally friendly. The second method is to use pressure generated by the rain to generate electricity with piezoelectric materials. The system can generate between 1 picowatt of continuous energy for smaller raindrops and up to 12 microwatts for larger drops. As Bojaya has a very rainy climate, the solution will work well in the weather. However, the solution is new technology, which means it is quite expensive, and it has some materials that are quite harmful to the environment. The last method is generating energy through biking, an aerobic activity that would be carried out in a PE class. It seeks to take advantage of wasted energy from the momentum of the biker and thus generate energy for the 7-hour school day. This solution is great as it has low installation costs and low maintenance, and it could add a PE class. However, the students must be constantly biking to produce energy and biking at a threshold velocity, and this may discourage some students or make students less interested. Here are some graphs of data for different age students and the amount of electricity that could be generated. This graph shows the amount of watts that could be generated per hour. In the end, the team created a decision matrix to figure out which solution would be the best. As can be seen in the matrix, the bike has the highest total, so the most potential comes from the bike idea. In the end, we believe that the next step would be to talk to the community and see if they would like the idea of bikes. We also want to explore adding a small solar panel that would work in addition to the bikes so that they could have some energy that would not be generated from biking. In conclusion, the bikes are the most efficient and affordable way to generate electricity for the school. We believe that the next steps would be to help the community integrate the bikes to their PE class routine, as well as guide them to build an optimal room to keep the battery. We also want to explore adding a small solar panel that would work in addition to the bikes so that our stakeholder can have some energy that would be human independent. We would like to give a special thanks to Dr. Parker, Dr. Caro, Dr. Brezen, Dr. Avila, and Edilberto Macchiato, the mayor of Bojaya. Thank you for watching.